Assalamu alaikum dear students. In the previous class we have solved some questions of miscellaneous exercise and there we are on question number 9 of that same exercise, that is miscellaneous exercise. And in that question we have to actually find the shortest distance between the lines whose vector equations are given by r is equal to 6i plus 2j plus 2k plus lambda times I minus 2j plus 2k, the vector equation of first line. And the vector equation of second line is r vector is equal to minus 4i plus 0j minus k plus mu times 3i minus 2k, 2j minus 2k, and that's the vector equation of line second. And we need to calculate the shortest distance between them. The formula for obtaining the shortest distance, we know that that's mod of, yes, v1 cross v2 dot a2 minus a1 divided by magnitude of v1 cross v2. This is actually the formula. This is actually the expression for calculating the shortest distance between two CQ lines. So these two lines are CQ lines and we have to find the shortest distance between them. So we will compare these two equations with the equation r is equal to a plus lambda times v, or a is equal to r vector is equal to a plus t times v. Comparing the equations, with r vector is equal to a1 vector plus lambda times v1 vector, and r vector is equal to a2 vector plus mu times v2 vector, we get, because they are the equations of lines which are passing through a point and parallel to a given vector. तो इक्वेशन फर्स्ट को r वेक्टर इज इक्वल टू a1 प्लस लैम्डा टाइम्स v1 से कंपेयर कर दो, we will get a1, we will get v1, and similarly from second we will get a2 and v2, and put the vectors in the formula in the expression and we will get the shortest distance between these two CQ lines. So we get a1 vector is equal to, what is the value of a1? A1 is the position vector of that point through which line first passes, and that is 6i plus 2j plus 2k. We will get v1 vector, and that's equal to vector which is parallel to line first, so I minus 2j plus 2k. Similarly, we will get the value of a2 vector, position vector of that point through which line second passes, and that's minus 4i plus 0j minus k, and we will get the value of v2 vector which is parallel to line second, and that must be 3i minus 2j minus 2k. So therefore we have to find the value of a2 minus a1, we have to find the value of v1 cross v2. So therefore v1 cross v2 is then equal to cross product of two vectors when they are expressed in terms of their components. v1 is a vector expressed in terms of components, v2 is a vector expressed in terms of components, and we have to find their cross product. So that is directly equal to determinant of I, j, k in the first row, scalar components of v1, that is 1, minus 2 and 2 in the second row, and scalar components of v2, that is 3, minus 2 and minus 2 in the third row. Expand the determinant by Laplace expansion, so implies vector v1 cross vector v2 is then directly equal to I times, lies in first row, first column, delete that, minus 2 into minus 2, that is plus 4, minus into minus is plus, 2 2s are again 4, minus j times, lies in first row, second column, delete that, 1 into minus 2, that is minus 2, minus 3 2s are, that is minus 6, plus k times, yes, lies in first row, third column, delete that, 1 into minus 2, that is minus 2, and minus into minus is plus, 3 2s are 6. So implies v1 cross v2 is then equal to 4 plus 4, that is 8i, minus 2 minus 6 minus 2, that is minus 8, minus 8 into minus j, that is plus 8j, and 6 minus 2, that is plus 4k. So the value of v1 cross v2 is 8i plus 8j plus 4k. we need the magnitude of V1 cross V2. So also magnitude of V1 cross V2, and that's equal to non-negative square root of 8 square plus 8 square plus 4 square, because the magnitude of a vector when that has been expressed in terms of components is directly equal to the non-negative square root of sum of squares of its scalar components. So implies magnitude of V1 cross V2 is then equal to, yes, square root of 64 plus 64 plus 16, that is 144, and square root of 144 is obviously equal to 12. So magnitude of V1 cross V2 is then equal to 12. Now we have to calculate the value of A2 minus A1. Also vector A2 minus vector A1, and that's equal to A2 minus A1, that is minus 4i minus 6i, so minus 10i. Yes, 0j minus 2j, so that is minus 2j. And similarly, minus k minus 2k, that is minus 3k. Therefore, the shortest distance between lines first and second, is, yes, mod of V1 cross V2 dot A2 minus A1 divided by magnitude of V1 cross V2, and that's equal to mod of, what is V1 cross V2? V1 cross V2 is 8i plus 8j plus 4k, so that is 8i plus 8j plus 4k, और इसका डॉट करना है एक वेक्टर A2 माइनस A1 के साथ, एंड दैट इज माइनस 10i, सो माइनस 10i minus 2j minus 3k divided by magnitude of V1 cross V2, and that's equal to 12. Calculate that thing, हमें क्या मिलेगा? Yes, we will get, so that's equal to the dot product of two vectors when they are expressed in terms of components. दो vectors का dot product जब वो components में express किए गए हैं तो उनका dot product किसके बराबर होता है? Sum of products of the corresponding scalar components. So 8 into minus 10, so mod of that is 8 into minus 10 plus 8 into minus 2, 8 into minus 2 plus 4 into minus 3, so 4 into minus 3 divided by 12, and that's equal to mod of, yes, 8 into minus 10, that's minus 80, 8 into minus 2, and that is minus 16, 4 into minus 3, and that's minus 12 divided by 12. So that will come out to be mod of minus 80 minus 16 is minus 96, and minus 96 minus 12 is equal to 6 plus 2, that is 8, 9 plus 1, and that's 10, so 108. So minus 108 divided by 12. Mod of minus 108 is obviously equal to 108, so 108 divided by 12. Now simplify that, we will get, yes, 2 5s are, 2 4s are, and 2 6s are, 6 1s are, 6 9s are, so the value must be equal to 9. So the shortest distance between these two CQ lines first and second must be equal to 9 units. The shortest distance between lines first and second is 9 units. So these two CQ lines are at a perpendicular distance of 9 units. So all about question number 9 of the miscellaneous exercise. Now we are on question number 10 of the miscellaneous exercise, and in that question number 10 we have a YZ plane and a line passing through 2 points 516 and 341 intersects the plane at some point, and we need to find the coordinates of that point of intersection of a line and a plane. तो हमारे पास एक प्लेन है जो वाइजर प्लेन है और एक लाइन है जो दो पॉइंट्स में से पास हो रहा है, और उस लाइन और वो प्लेन आपस में इंटरसेक्ट कर रहे हैं एक पॉइंट पे। तो जिस पॉइंट पे वो इंटरसेक्ट कर रहे हैं उस पॉइंट के हमें चाहिए कोऑर्डिनेट्स। तो सबसे पहले हम मेंशन कर देंगे वाइजर प्लेन। तो वाइजर प्लेन की इक्वेशन क्या होती है, x इज इक्वल टू 0। तो सबसे पहले मेंशन कर देंगे द इक्वेशन ऑफ वाइजर प्लेन इज। तो वाइजर प्लेन की इक्वेशन क्या होती है, x इज इक्वल टू 0, बिकॉज दैट इज एक्चुअली फॉर्मड बाय y एक्सिस एंड z एक्सिस। तो उसमें x कोऑर्डिनेट पॉइंट जितने भी होंगे उन सारे पॉइंट्स का x कोऑर्डिनेट जो होगा 0 होगा, एंड दैट्स व्हाई द इक्वेशन ऑफ वाइजर प्लेन इज x इज इक्वल टू 0। वी आर कीपिंग दैट इक्वेशन एज इक्वेशन नंबर फर्स्ट। नाउ हमारे पास एक लाइन है जो दो पॉइंट्स में से पास हो रहा है, तो हम उसकी इक्वेशन निकालेंगे बाय 2 पॉइंट फॉर्म। नाउ द इक्वेशन ऑफ लाइन, now the equation of line passing through, now the equation of line passing through the points, जो दो पॉइंट्स में से पास हो रही है, that is 5, 1, 6 and 3, 4, 1 is। तो क्या बनेगी इक्वेशन ऑफ लाइन विच इज पासिंग थ्रू 2 points by 2 point form, that is x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1, and that's equal to z minus z1 divided by z2 minus z1, because by 2 point form। Because by 2 point form, right? So implies this can be written as x minus, what is x1, so 5, divided by x2 minus x1, that is 3 minus 5, is equal to y minus y1, that is 1, divided by y2 minus y1, that is 4 minus 1, is equal to z minus z1, that is 6, divided by 1 minus 6, z2 minus z1, that's 1 minus 6. So implies this can be written as x minus 5 divided by minus 2, 3 minus 5 is minus 2, which is equal to y minus 1 divided by 4 minus 1, that is 3, and that's equal to z minus 6 divided by 1 minus 6, that is minus 5. So x minus 5 divided by minus 2, y minus 1 divided by 3 is equal to z minus 6 divided by 5 would be the equation of this line which is passing through 2 points। And suppose इन सारे रेशोज को हम किसी स्केलर t के बराबर ले रहे, से सपोज इसको हम t के बराबर ले रहे, where t is a real number। सपोज t कोई रियल नंबर है, क्योंकि रेशोज हैं तो इन सारे रेशोज को हम किसी फिक्स्ड रेशो t के बराबर ले रहे हैं। सो इंप्लाइज यहां से हमें क्या मिलेगा, x माइनस 5 डिवाइडेड बाई माइनस 2 ये भी t के बराबर, y माइनस 1 बाई 3 ये भी t के बराबर, z माइनस 6 डिवाइड बाई माइनस 5 ये भी t के बराबर। सो x माइनस 5 डिवाइडेड बाई माइनस 2 को मल्टीपल कर दो t से, तो क्या आएगा, x माइनस 5 इज इक्वल टू माइनस 2t, y माइनस 1 इज इक्वल टू 3t and z minus 6 is equal to minus 5t। Is it clear? So implies this can be written as x is equal, ये minus 5 है, उस साइड में plus 5 बनेगा, so plus 5 minus 2t, y is equal to 1 plus 3t and z is equal to plus 6 minus 5t। So we have actually got the value of x, y and z, but what is x, y and z? Coordinates of any point lying on the line। जो कोई भी पॉइंट होगा उसके कोऑर्डिनेट्स जो होंगे, इस लाइन पे जो लाई करेगा उसके कोऑर्डिनेट्स होंगे ऑफ द फॉर्म 5 माइनस 2t, 1 प्लस 3t, 6 माइनस 5t। लेकिन ये पॉइंट जो पॉइंट ऑफ इंटरसेक्शन ऑफ प्लेन एंड लाइन है वो भी यही पॉइंट है, वो भी एक पॉइंट इसी लाइन पे लाई कर रहा है, तो इसके भी कोऑर्डिनेट्स होंगे। सो इसके भी कोऑर्डिनेट्स होंगे ऑफ द फॉर्म, यस, 5 माइनस 2t, 5 माइनस 2t, 1 प्लस 3t, 1 plus 3t and 6 minus 5t, 6 minus 5t। That is यहां पे मेंशन कर देंगे the coordinates of any point lying on the line, therefore coordinates of any point lying on the line are, क्या होंगे उसके कोऑर्डिनेट्स? x कोऑर्डिनेट होगा 5-2t, y कोऑर्डिनेट होगा 1+3t और z कोऑर्डिनेट होगा 6-5t. इज दैट क्लियर? नाउ दिस पॉइंट, क्योंकि ये पॉइंट भी इसी लाइन पे लाई कर रहा है, लेकिन ये पॉइंट है पॉइंट ऑफ इंटरसेक्शन ऑफ लाइन एंड प्लेन. नाउ दिस पॉइंट वुड बी द पॉइंट ऑफ इंटरसेक्शन ऑफ लाइन एंड प्लेन. नाउ this point would be the point of intersection of line and plane if, अगर ये पॉइंट प्लेन की इक्वेशन को सेटिस्फाई करेगा. तो प्लेन की इक्वेशन क्या है? x इज इक्वल टू 0. तो यहां पे x का वैल्यू क्या है? 5-2t इज इक्वल टू, सो इफ 5-2t इज इक्वल टू 0, दैट इज इफ t का वैल्यू क्या आएगा? यस, -5 +5 को साइड में ले लो, सो -5, अब -2 डिवाइड होगा, सो t का वैल्यू आएगा 5 डिवाइडेड बाय 2. सो t का वैल्यू अगर 5/2 आ रहा है तो वी विल गेट द रिक्वायर्ड कोऑर्डिनेट्स ऑफ द, so the coordinates of the required point of intersection are, therefore coordinates of point of intersection, therefore coordinates of point of intersection of line and plane are, तो क्या होंगे उसके कोऑर्डिनेट्स? यस, 5-2t, so that is 5-2, t का वैल्यू 5/2, कमा y कोऑर्डिनेट क्या आएगा? 1+3t, so 1+3 into t का वैल्यू 5/2 और z कोऑर्डिनेट क्या आएगा? 6-5t, so 6-5 into t का वैल्यू 5 डिवाइडेड बाय 2. तो क्या मिलेंगे रिक्वायर्ड कोऑर्डिनेट्स? एंड दैट्स equal to, yes, 2 and 2 will cancel out, 5-5 that is 0, तो x कोऑर्डिनेट इस पॉइंट का 0 आएगा, राइट? y कोऑर्डिनेट क्या आएगा? 1+3 5 15/2, 1+15/2 क्रॉस मल्टीपल कर दो, 2 1 2 + 15 that is 17 डिवाइडेड बाय 2, तो इसका y कोऑर्डिनेट आएगा 17 डिवाइडेड बाय 2 और z कोऑर्डिनेट क्या आएगा? 6-25/2, 2 6 12 -25, 12 - 25 that is -13, so -13 डिवाइडेड बाय 2, तो इसका z कोऑर्डिनेट आएगा -13 डिवाइडेड बाय 2, राइट? सो एक लाइन जो पास हो रहा है थ्रू द पॉइंट्स 5 1 6 एंड 3 4 1 और वो प्लेन वाइजर प्लेन को इंटरसेक्ट कर रहा है एक पॉइंट पे, उस पॉइंट के कोऑर्डिनेट्स वहां पे होंगे 0, 17 डिवाइडेड बाय 2 -13 डिवाइडेड बाय 2, right? So they must be the coordinates of point of intersection of line which is passing through the points and YZ plane. So that was all about question number 10. Now question number 11 and question number 12 are just the mirror images of question number 10. 11 और 12 बिल्कुल इसी तरह आपको करना है, so you can do them by yourself. So 11 और 12 आप खुद करोगे. Now we are on question number 13 of this miscellaneous exercise, and in that question we have two given planes represented in terms of the Cartesian equations as x plus 2y plus 3z minus 5 is equal to 0, plane first, and 3x plus 3y plus z is equal to 0, and that's the equation of plane second. Now we have another plane which is passing through the point -1, 3 and 2, and that is perpendicular to the planes, first and second, and we need to calculate the equation of that plane. So actually we need to calculate the equation of plane third, which is passing through the point -1, 3, 2 and is perpendicular to planes first and second. Now that third plane is actually passing through a point, तो उसकी equation हम 1 point form से निकाल सकते हैं. a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. So any plane passing through the point, कौन से पॉइंट में पास हो रहा है, -1 3 2 इज, तो क्या बनेगी इसकी इक्वेशन, a इंटू x माइनस x1 प्लस b इंटू y माइनस y1 प्लस c इंटू z माइनस z1 इज इक्वल टू 0 बिकॉज by 1 point form of equation of plane. So implies this can be written as a into x minus, what is the x coordinate of a point, that is -1, so it will become x plus 1 plus b into y minus y1, what is y1, so that is 3 plus c into z minus z1 and that's 2 is equal to 0. We are keeping that plane as plane number 3rd. Now it is given that the plane 3rd is perpendicular to plane 1st as well as perpendicular to plane 2nd. When two planes are perpendicular, we know that the sum of products of their attitude numbers must be 0. Now since the plane 3rd is perpendicular to plane 1st and plane 2nd, now since the plane 3rd is perpendicular to planes 1st and 2nd, therefore तब क्या होगा जिगरा, प्लेन 3rd और प्लेन 1st के एटीट्यूड नंबर्स का सम ऑफ प्रोडक्ट 0 के बराबर होगा और प्लेन 3rd और प्लेन 2nd के एटीट्यूड नंबर्स का सम ऑफ प्रोडक्ट फिर से 0 के बराबर होगा. So what are the attitude numbers of plane 3rd? A, B, C. What are the attitude numbers of plane 1st? 1, 2, 3. So A into 1. So therefore A into 1 plus B into 2, B into 2 plus C into 3 must be equal to 0. And अब ये plane 3rd, plane 2nd पे भी perpendicular है. So A into 3 plus yes b into 3, so b into 3 plus c into 1 must be equal to 0. Why? Because when planes are perpendicular, the sum of products of their attitude numbers, the sum of products of their attitude numbers is 0, because when two planes are perpendicular to each other, the sum of products of their attitude numbers is 0. So implies यहां से क्या मिलेगा, a into 1 that's a plus b into 2 that is 2b plus 3 into c that is 3c is equal to 0. We are keeping that equation as equation number 4th. A into 3 that is 3a plus b into 3 that is 3b plus c into 1 that is c is equal to 0. We are keeping that plane as plane number 5th. Now in plane 3rd we have ABC, in plane 4th we have again ABC, and in plane 5th we have again ABC. So we will eliminate A, B and C from A, B, C from planes 3rd, 4th and 5th by determinant method, जैसे बहुत बार हमने कर रखा है, क्योंकि ये एक्चुअली बनता है एक सिस्टम ऑफ इक्वेशंस जिसको हम लिख सकते हैं AX is equal to B, where A मैट्रिक्स जो रहेगी that is ABC, ABC and ABC. X रहेगा x plus 1, y minus 3, z minus 2. Similarly 1, 2, 3, 3, 3, 1. एंड RHS जो है 0 0 0, यहां पे भी मींस RHS की मैट्रिक्स जो है दैट्स अ जीरो मैट्रिक्स. तो रिजल्ट क्या आएगा, AX इज इक्वल टू 0. फिर A इनवर्स से मल्टीपल कर दूं तो हमें मिलेगा x इज इक्वल टू 0, x इक्वल टू O, एक्चुअली x इज इक्वल टू O. फिर डिटर्मिनेंट ले लो तो डिटर्मिनेंट ऑफ x किसके बराबर आएगा, 0 के बराबर. सो एलिमिनेटिंग A, B and C from equations 3rd, 4th and 5th we get eliminating Eliminating A, B and C from equations 3rd, 4th and 5th by determinant method. By determinant method we get, yes, what we get? Determinant of, क्या है यहाँ पे वेरिएबल्स x plus 1, y minus 2, y minus 3, z minus 2. So first row में x plus 1, y minus 3, y minus 3, z minus 2, so z minus 2. Yes. यहाँ पे a का कोफिशिएंट 1, so 1, b का कोफिशिएंट 2, so that is 2, and c का कोफिशिएंट 3, so that is 3. यहाँ पे x, y और a, b and c का कोफिशिएंट क्या है? 3, 3 and 1. So यहाँ पे 3, 3 and 1 and that must be equal to 0 because eliminating a, b and c from equation 3, 4th and 5th, right? By determinant method. So solve the determinant, expand it with the help of Laplace expansion implies we get x plus 1 into lies in first row, first column, delete that, 2 1s are 2, minus 3 3s are 9. Minus times y minus 3 क्योंकि दूसरी term जो आएगी minus आएगी because lying in first row. Second column, delete that, 1 into 1 that is 1, 3 3s are minus 9. Is that clear? तो तीसरी term plus आएगी, so plus z minus 2 into, yes, lies in first row, third column, delete that, 1 into 3 that is 3 and 3 into 2 that is 6 and that's equal to 0. Implies this can be written as x plus 1 into 2 minus 9 that is minus 7 minus y minus 3 into 1 minus 9 that's minus 8 and plus z minus 2 into 3 minus 6 that is minus 3 and that's equal to 0. Simplify the equation, implies minus 7 into x that is minus 7x, minus 7 into 1 that is minus 7, minus into minus is plus, 8 into y that is plus 8y, and 8 into minus 3 that is minus 24, minus 3 into z that's minus 3z, and minus 3 into minus 2 that is plus 6 is equal to 0. So implies this can be written as minus 7x plus 8y minus 3z, yes, minus 7 minus 24 कितने हो गए? minus 31, minus 31 plus 6, minus 31 plus 6 कितने बनेंगे? That is 25. So minus 25 is equal to 0. So minus 7x plus 8y minus 3z minus 25 is equal to 0 must be the equation of that plane which is passing through the point minus 1, 3, 2 and is perpendicular to the planes first and second. और हम इस equation को ऐसे भी लिख सकते हैं, और this can be written as माइनस से मल्टीपल कर दो दोनों साइड तो क्या आएगा? 7x minus 8y plus 3z, yes, plus 25 is equal to 0, which is the equation of required plane. Which is the equation of required plane. So 7x minus 8y plus 3z plus 25 is equal to 0 would be the equation of that plane which is passing through the point minus 1, 3, 2 and is perpendicular to each of the planes first and second. So all about question number 13 of this exercise. Now we are on question number 14 of the miscellaneous exercise, and in that question number 14 we have actually a plane whose vector equation is r dot 3i plus 4j minus 12k plus 13 is equal to 0, and it is given that 2 points whose coordinates are 1 1p and minus 3 0 1 are equidistant from the plane. So the distance of point 1 1p from the plane is same as the distance of minus 3 0 1 from the plane. We need to calculate the value of this unknown p. So here we will directly find the distance of point 11p from the plane and the distance of minus 301 from the plane and equate these two distances because it is given that these 2 points are equidistant from the plane. So दे रखा है कि ये दो पॉइंट्स इक्विडिस्टेंट हैं फ्रॉम द प्लेन. जब ये दोनों पॉइंट्स इक्विडिस्टेंट हैं फ्रॉम द प्लेन तो डिस्टेंस ऑफ फर्स्ट पॉइंट फ्रॉम द प्लेन मस्ट बी इक्वल टू डिस्टेंस ऑफ सेकंड पॉइंट फ्रॉम द प्लेन. लेकिन डिस्टेंस ऑफ अ पॉइंट फ्रॉम अ प्लेन की जो एक्सप्रेशन होती है दैट इज कैलकुलेटेड बाय मॉड ऑफ ax1 प्लस by1 प्लस cz1 प्लस d डिवाइडेड बाय स्क्वायर रूट ऑफ a स्क्वायर प्लस b स्क्वायर प्लस c स्क्वायर. मींस प्लेन की इक्वेशन जो है होनी चाहिए इन कार्टेशियन फॉर्म. तो सबसे पहले हम वेक्टर इक्वेशन को चेंज करेंगे इनटू कार्टेशियन फॉर्म. द गिवन इक्वेशन ऑफ प्लेन इज the given equation of plane is yes r dot 3i plus 4j minus 12k plus 13 is equal to 0. तो इस वेक्टर फॉर्म की कार्टेशियन फॉर्म क्या बनेगी? द कार्टेशियन इक्वेशन ऑफ दिस प्लेन इज the Cartesian equation of this plane is. तो वेक्टर फॉर्म में से आप कार्टेशियन फॉर्म कैसे निकालते हो? बहुत सिंपल है. जगह चाहे आप लाइन की निकालोगे या प्लेन की निकालोगे तो सिंपली यू हैव टू पुट द वैल्यू ऑफ आर वेक्टर. आर वेक्टर इज द पोजीशन वेक्टर ऑफ अननोन पॉइंट. अननोन पॉइंट हैज द कोऑर्डिनेट्स x, y, z. So r vector must be then equal to xi plus yj plus zk. सो आर वेक्टर का वैल्यू है एक्स आई प्लस वाई जे प्लस जेड के. फिर एक्स आई प्लस वाई जे जेड के और इस वेक्टर का डॉट कर दो तो क्या आएगा? x इंटू 3 दैट इज 3x प्लस y इंटू 4 दैट इज 4y प्लस z इंटू माइनस 12 दैट इज माइनस 12z माइनस प्लस 13 इज इक्वल टू 0 एंड कीप दैट इक्वेशन एज इक्वेशन नंबर फर्स्ट. So this equation from vector equation we have directly evaluated the Cartesian equation of the plane. अब दे रखा है कि पॉइंट 11p की डिस्टेंस फ्रॉम द प्लेन पॉइंट -301 की डिस्टेंस फ्रॉम द प्लेन के बराबर है. यानी ये दो डिस्टेंसेस आपस में सेम है. These two points are equidistant from the plane. Now distance of point point 11p from plane first is equal to the distance of point -301 from plane first. Therefore distance of a point from a plane के लिए फॉर्मूला क्या होती है? मॉड ऑफ ax1 a का वैल्यू 3 तो x1 इज द x कोऑर्डिनेट ऑफ अ पॉइंट दैट इज 1 प्लस by1 b का वैल्यू यहां पे 4 बिकॉज a b एंड c आर द एल्टीट्यूड नंबर्स ऑफ द प्लेन. 4 इंटू y का कोऑर्डिनेट दैट इज 1 प्लस दैट इज c. यहां पे c का वैल्यू -12 सो -12 इंटू C z1. What is the value of z1? That is p and plus d that is plus 13 divided by square root of a square plus b square plus c square that is 3 square plus 4 square plus -12 square and that must be equal distance of -301 from plane first that is again mod of ax1 that is 4 into इस समय x1 का वैल्यू 3 so 4 into -3 plus 4 into 0 so that is 4 into 0 3 यहां पे सॉरी a का वैल्यू 3 है so 3 into -3 4 into 0 plus -12 into c that is 1 और plus d that is 13 divided by square root of a square plus b square plus c square that is again 3 square plus 4 square plus minus 12 square. So implies this can be written as, यहाँ पे भी डिनोमिनेटर में स्क्वायर रूट ऑफ 3 स्क्वायर प्लस 4 स्क्वायर माइनस 12 स्क्वायर, यहाँ पे भी डिनोमिनेटर में 3 स्क्वायर प्लस 4 स्क्वायर माइनस 12 स्क्वायर, तो ये कैंसिल होगा. तो क्या बचेगा, मॉड ऑफ minus 3 1s are 3, 4 1s are 4, that is 3 plus 4, that is 7, 7 plus 13, that is 20. So 20 minus 12p must be equal to 3 into minus 3, that is 9. So यहाँ पे minus 9, ये 0, ये minus 12, minus 9 और minus 12 कितने हो रहे हैं, that is minus 21, minus 21 plus 13, minus 21 plus 13 कितने आएंगे, that is 9. Minus 21 plus 13, 11 में से 3, तो that is 8. So 8 divided by mod of 8 implies mod of 20 minus 12p must be equal to mod of 8 is equal to 8, because 8 is positive and mod of a positive number is again that positive number. So implies, अब यहाँ पे mod of 20 minus 12p है, तो mod के कितने वैल्यू होंगे, 2, एक प्लस दूसरा माइनस, so 20 minus 12p, 20 minus 12p must be then equal to plus minus 8. So implies minus 12p must be equal to plus minus 8 minus 20, क्योंकि plus 20 RHS में बनेगा minus 20. So which further implies that p का वैल्यू क्या आएगा, p must be equal to plus minus 8 minus 20 plus minus 8 minus 20 divided by minus 12, क्योंकि minus 12 LHS में मल्टीपल है तो उस साइड में डिवाइड होगा. So implies p must has the value, एक plus 8 minus 20, plus 8 minus 20 is minus 12, so minus 12 divided by minus 12, और दूसरा वैल्यू minus 8 minus 20, that is minus 28 divided by minus 12. तो implies p का वैल्यू क्या आएगा, minus 12 by minus 12, that is 1, and minus 28 divided by 12, तो क्या वैल्यू आएगा, 4 7s are, minus and minus will cancel out, and 4 3s are, that is 7 divided by 3. So the value of p is either 1 or 7 divided by 3, such that the point is 1 1 p and minus 3 0 1 are equidistant from the plane r dot 3i plus 4j minus 12k plus 13 is equal to 0. तो इस unknown p का वैल्यू या 1 आएगा या 7 divided by 3 आएगा, such that ये दो points 1 1 p और minus 3 0 1 they are equidistant from the given plane. So all about question number 14 of the miscellaneous exercise.